Hey, it's Seth. Before we get started, I want to take a quick moment to mention a way you can support the Concrete Logic podcast. Whether you're looking to expand your concrete knowledge or want to keep the show going, check out the Concrete Logic Academy at www.concretelogicacademy.com. You can always make a donation directly at www.concretelogicpodcast.com. Any amount helps, and we truly appreciate your support. Now let's get into today's episode. And welcome to another episode of the Concrete Logic podcast. And today I have Derek Cressman, president of Durable Surfaces, and they are a polishing and a dry finishing contractor. Is that correct, Derek?
Yeah, we kind of sum up the services as repairs and technical grinding.
Yeah.
Concrete after it gets hard.
There you go. Yeah. So today what we're going to talk about how do FF and FL numbers shape the concrete floors we rely on today and what they are missing for the future. As logistics and robotics continue to grow, how will the needs for floor specifications evolve beyond FF and FL ratings? What's the difference between how the U.S. industry measures floor flatness and levelness versus what robotics and logistics demand for optimal performance? And lastly, how can we ensure our floors are ready for the robots of tomorrow, and what new specifications should we be looking at? So, Derek, we were discussing before we hit record today with the demands of robotics. There's a gap as far as what our specifications are trying to deliver. Because as a concrete guy, you said you're the contractor that works with concrete after it gets hard. I work for a contractor. We work it when it's still wet. Our standard is an FFFL number, but why you're joining us today is you're saying for new facilities that have robotics, there's a gap there that we need to fill, and that's where your company comes in. So can you introduce us to that, and we'll get started?
That's right, Seth. Thanks for having me. Appreciate the time and appreciate the willingness to discuss this topic. So again, my name is Derek Cressman. I'm the president over at Durable Surfaces and one of the partners. And we specialize in the technical grinding and the repair of concrete in industrial facilities, be it for a regular forklift situation or one of these more advanced robotics programs. What I was talking to Seth about before we started here today was just how much the world is changing in the world of industrial logistics and the types of machinery that they're putting in. And what we're finding really is that FFFL is beginning to create a bit of a confusion in the industrial market. The reason being is we have a tremendous amount of clients that tell us, well, we hit these FFFL numbers, but this machine doesn't work right, or we can't put this installation in. Our environment's not quite right. Unfortunately, most of the time, they're finding this out after the fact. What am I saying to a group of concrete guys? It's be cautious with FFFL moving forward as Industry 4.0 comes online in the logistics world. FFFL is really a statistical sampling of the floor. It doesn't necessarily cover every characteristic of the floor, but it is the way that we measure it here in the US. So it does still correlate. If you have a very high FFFL number, you may hit a lot of the criteria that you need to. However, you may not hit all of them. You can't just rest on your laurels and say that we have a good FFFL number, we're going to be able to hit the robotics environment that's necessary. It's required that we do a little bit more research. We're finding a lot of clients get themselves into trouble because they're picking up a spec building or they're going with more traditional specs on FFFL only to come and find out the environmental information coming out of the robot provider is more stringent or different. Ways that this can be is that FFFL is just a sampling. During a free movement floor, we care about every direction, not just a couple of plus signs or hashtags or X's on the floor the way we test FFFL. Instead, we're looking for a much more continuous picture because the robots can move anywhere on the floor. Or we come back to an FMIN spec or defined traffic floor where we need to understand exactly the wheel paths and exactly how flat the floor needs to be. In either one of these instances, F and FL are not enough alone to ensure that the client will have the floor that they need to run their program.
Yeah. Let's There's a couple things you mentioned that I want to make sure we define for folks. So you said a free movement floor. What is a free movement floor?
Well, it's exactly what it sounds like. So a free movement floor is a floor where the robots can travel in any direction. It's an undefined traffic pattern. Most of the time, from what we have seen in our experience on the floors, they're not moving in diagonals, but they are typically moving in a north-south or an east-west direction in a defined area within the building. We call those free movement floors because they can track anywhere.
Okay. And then you briefly mentioned F-min. Let's define that. So what would be an F-min floor?
So an F-min floor is more like we call them, a broader name is a defined traffic floor. And so in a defined traffic environment, the fork truck is restrained to certain aisleways. Think about a very high-pick warehouse. The forklift has to be on a very defined traffic, and we will only analyze and correct the areas within that defined traffic. A lot of times these machines run on wire guides, so they cannot deviate from their path. They are locked on and can go. That's more of a defined traffic. F-min's a very stringent spec. Coming out of Europe, there's a VDMA spec that's even more stringent. So these specs are very, very high tolerance and require a significant amount of layout and front-end work to make sure that the end result is a positive, high-efficiency result for the client.
Yeah, so for folks that aren't familiar with measuring how we measure FF and FL, we typically use what they call a dipstick, and it's a machine that you walk across the floor, kind of rolls across the floor, and usually you do it over 10 feet, right? 10 feet is usually...
Minimum of 10 feet, yeah.
Minimum of 10.
That's for levelness, yep.
Yep. So there's no, I haven't seen, maybe you've seen, where they define where you got to take the measurement at. So they don't tell you, hey, you got to take your FF and FL in these areas. So it's kind of up to the contractor where they do that. And the third party, because typically a third party guy goes in there and does his measurement as well. I don't know if we do it, but do all contractors kind of self-measure as well?
I think a lot of the big guys do that are working in these industrial markets with us. A lot of those guys are out there walking their floors because they want to know that the testing agency is doing it right.
Yeah. So that's what I guess I'm trying to set the table for you, Derek, that's how the floors are measured by if the specifications call for that. So typically you'll have, if you look in the specifications, they say, hey, that you need this is your FF you got to hit, this is the FL you got to hit. And then, right now, the way, have you seen the measurement requirement defined a different way other than using a dipstick? Like, have you seen them say, hey, you got to use a scanner? Do you have to use a 3D scanner? Have you seen that at all?
Yeah, it really depends. I mean, you guys actually did a really nice job with Leo Zhang there from laser scanning in one of your previous podcasts. Yeah. But yeah, there's multiple ways to kind of go at this problem. For a free movement floor, yeah, a lot of times the best way to begin to look at that is a scanner because it gives you a good picture of the floor. The problem with the scanners is precision-wise, we can't quite get down on what some of the robot manufacturers need. So there's some additional measures. A lot of times what happens is a tremendous amount of statistical work, either by using a walking profiler such as a dipstick or a 1155, or what's known as a rolling profilograph, which is basically a few dipsticks put together on wheels that analyzes the floor and gives you a topography of the floor. Then it's all stitched together through a litany of math, and you get a organized chart that begins to tell you which parts of the floor fall within the bandwidth and which do not. Really depends on the spec. That's free movement. In defined movement, floors, the fastest, most easiest way is by far the rolling profilograph instrument. You can do it with the walking D-meters, but anybody that's ever done that knows that it is a very long and painful process, and if you mess up halfway along the way, it'll make you absolutely crazy.
Yeah, and the other challenge too, so the concrete contractor, third-party guy that's doing the FF and FL measurements, they have a window of time to do it in. It has to be between 24 and 72 hours. So they can go over there and measure it in that window, hit their numbers. But what happens to the concrete after that, Derek?
Well, here in the Northeast, it twists and turns and curls and carries on. No matter how much we try, Everybody seems to experience some form of movement or subbase or issue, but concrete, I feel like, is a living, breathing thing, and it does twist and turn on us here.
Yeah. Like I said, you hit your FFFL numbers, and that meets the spec. And then, but what you're saying is, due to the newer robotics and equipment that are used in these warehouses, that's not enough.
That's exactly right.
So what do you have to do to? I guess where does from that are do the robotics manufacturers? Do they give that to the contractor? Who do they give that information to, and what does that look like?
So that's one of the trickiest parts, and that's where we are trying to create some elbow room a little bit in the industry. So a lot of times these buildings are being built before anybody even knows which robotics package is going into it, or maybe that problem hasn't been solved for quite yet as land development's approved and we're beginning to build these buildings out. So we're going with what we know here in the States with an FFFL number. And that's not a bad way of doing things, because if you push the FFFL numbers up, we know that the place and finish guys are going to need to be paid more to take that risk. That makes perfect sense. But the answer to who is creating these rules is each robot manufacturer. So when our clients sign up for whatever sophisticated automation system, ASRS system, or AGV system that they want, it comes somewhere deep within the paperwork and environmental spec. And this environmental spec begins to dictate how that floor is going to interact with the fork truck. Sometimes our clients get it up front. Sometimes they find out the hard way, unfortunately, that they didn't meet the spec. But each one's a little bit different. The robot manufacturers do a really nice job most of the time of knowing exactly what their systems can handle and cannot handle. It's a function of height, it's a function of speed of the robot, and it's a function of how tight the building is laid out. So each one's a little bit different, but it is an important question to ask. Understanding the environment which their specific selection needs to run in is a critical piece of the puzzle as automation begins to take hold and Industry 4.0 comes into our logistics program in America.
So you mentioned, I didn't know if you caught or you explained. So AGV is automated. I had to look this up. Automated guided vehicles, right?
Yep.
And then
did
you say AMR?
Yeah, well, AMR is another piece of the puzzle in this. There's 100 different acronyms and things like that, so I apologize. Yeah, an AMR is an autonomous mobile robot, I believe, is the name for that. And then ASRS is automated storage and retrieval systems. And these are all different varying types of robots that are beginning to find a foothold in large industrial buildings and e-commerce fulfillment centers throughout the country.
Okay. And I assume these are all foreign manufacturers. Is that correct? Is that a correct statement?
A significant amount of the ones that we see are coming out of Europe, but it's anybody's guess. Anybody can make these things. We just we adapt as we see them. Our job is to adapt the floor to whatever is put in front of us.
So when you get these requirements from these robotic manufacturers, what does it look like?
Typically, it comes in table form, and it really depends. Going kind of a little bit of recall here, whether or not you're going to free movement or to an FMIN or VDMA spec. So in free movement, you're looking at a table typically with a series of criteria which correlate loosely to a flatness over a gauge, be it a meter, 2 meters, 4 meters, or 10 meters, and then a level grid usually laid out over 3 meters. And then you have a requirement of just how much gap under straight edge, for lack of a better term, you can have in this environment.
Yeah, we did an episode.
That's how the free movement floor works. And then that can happen in any kind of direction as you're trying to carve out the problem on the floor. In defined movement, that's typically classified by a number. In the FMIN system, it would just be an FMIN 100 or an FMIN 60. And you can peel back the onion on that a little bit further and say, well, how much is it in the transverse direction, which is how much wobble does the forklift have left to right, versus how much in the pitch direction longitudinally forward and backwards. So there's a litany of information that you can begin with and then peel back to make sure that you're trying to get to the right place for the client.
So if you're part of a project team and you are building one of these facilities, what recommendations would you give them as far as making sure they're protecting themselves, that there's no confusion on what the deliverable is. So if you're a concrete contractor and there's an F number in there, is there a recommendation you would have to say these are the things that you would look out for in a spec to make sure that one, that you're protecting yourself from future confusion? I guess also everyone's on the same page as far as what the deliverable looks like at the end. Because you were talking before, I guess, to fill everybody in. So I was part of a team that built one of these Amazon robotic distribution facilities, and the specifications were, and the project team were all set up for a company like Derek's to come in and do what we would call the dry finishing. So there was an FFL number for us to hit. We hit that, and then there already was money allocated to having Derek come in. But what Derek shared with me was not all of the companies out there are refined as Amazon, and they understand that there's that second step for a dry finisher to come in after the concrete contractor delivers delivers the FFFL per the spec. There's a bit more that has to happen for the robotics and the equipment to work. So what should we be looking out for? Circle back around, Derek. Sorry.
No problem. So, yeah, I mean, I think that's a really important piece. And really, a lot of it is setting good expectations. I think you hit the nail on the head. I'm not sitting here advocating that we change the world. I think that FF and FL is probably the way that place and finish contractors are going to want to do this. And that's fine. It's really setting the expectations upstream. We have a tremendous amount of end user clients that come in and they're like, well, I had an FFFL of a 75, 45, or pick a number. Of course, we can put this robotics platform on, and come to find out after the fact that things didn't really work out that way. And so it's really understanding what FF and FL are telling you. I think a perfectly good way to protect the concrete contracting community is still within FF and FL. As long as they understand, everybody understands, including the testing agency and the owner, what you are delivering. Because ultimately, when the owner comes in and their robotics package doesn't work that well, and the environmental page doesn't really match up with the FF and FL that was delivered on the floor, that's when these more difficult conversations start. And that's when we come in and say, hey, give us a little bit of elbow room as the technical grinding service so that we can solve the problem together and get a floor that was a perfectly good floor and met spec in FF and FL, but now we can get it to the environmental requirements of the robot, which may or may not correlate with the FF and FL system. So it's really, there's not a lot a concrete contractor can do other than sign up for the specification and then make sure that the testing and acceptance is very well defined. The worst thing in the world is when you have an owner that's upset because their environmental is disconnected from the floor that was delivered to them. And it's just making sure that there's open lines of communications. And the way we do construction here, a lot of times we're off to and running prior to maybe they've making a selection of the package, or maybe they don't know exactly what's going in the building. They're down to 3 different vendors for a robotics platform. Those 3 different vendors all have 3 different environmental criteria that may or may not correlate with the number. So that it's getting the project team to understand there's a gray space in there that needs to be talked about. It can't just be swept under the rug, because fixing the problem after the fact is extremely difficult.
Yeah. So are we in the States, are we doing, I don't want to say something wrong, but are we doing something different than, say, Europe as far as how they address this? Are they doing it differently than we do?
I think that I guess the answer to that question is I don't think we're doing anything wrong. We just build very fast here. So with speed comes some potential agitation. Maybe the floor specs are already set, and maybe the floor's already going in long before we know even who's going in the building, let alone what robot package they're bringing with them. So it's very hard to deliver a robot-ready floor when you don't know what robot you're getting ready for. In Europe, I think that they are a little bit more thoughtful in kind of what the end result is going to be, and timing-wise, what they are willing to allocate to see a project through. That's some of the feedback that we've been given by some of our European peers as we begin to ask questions on how they've surmounted some of the issues that we face from day to day.
Yeah. Is there any groups that you're aware of, or maybe you're a part of, that are addressing this in a, like an ACI or something like that, where this is I guess someone's documenting this and contractors can point to that or use it as a guide to make sure they're, going at this the right way?
I think there's a lot of conversations about changing or beginning to publish a document, something like that.
Yeah.
I don't know that anybody has grabbed a hold of the whole idea yet and ran with it, but I've heard in certain circles around ACI the idea has been brought up, but nobody's grabbed the whole thing and put their arms around it, because every environmental specs seems to be a little bit different. They're all close but different. And so the other thing that's really interesting about as our industry, steadfast, we do things the way we do them, meets tech industry and constant change, it's very hard to keep up with their specs because they're improving these robots daily. We're on some floors where the challenge has been, fix the floor as best as you can within this budget, and simultaneously look at the robot contractor and say, you make that robot work with this floor, the best that we can deliver it. So there's such an evolution. We're all learning so fast. It's really hard to wrap your arms around it and say, well, these are the hard and fast rules, because there is this very large gray area.
Yeah. Yeah, I was thinking when you were saying that there are a lot of speculative warehouses that were built over the last handful of years. I could see where that's a problem, where someone goes, yeah, I'll buy that building and I'm going to, either be a warehouse or I'm going to manufacture something in there, and you plan on using these certain robots. That I wonder how often people actually consider the floor flatness or the condition of the floor before they actually make that purchase.
Well, it's a very interesting stat that some of our marketing team dug up through some of our conversations in the industry is that 40% of automation failures actually begin with the floor. So I guess that begins to answer some of that question. We do a tremendous amount of what the industry seems to be calling brownfield site rehab. So I'm living in a warehouse, maybe I can't find employees, and so we're going to switch to some form of automation. We do a ton of repair, not just technical grinding, but a ton of repair work to get these facilities ready for the robots to come in. And a lot of these things are often overlooked, and I can give some pretty wild examples of things that we've kind of run across through the years. We had one experience with a very large bakery client that couldn't find employees, bought a awesome automation system and ran it. And the problem that they were having is that the joints, they were curled and then beginning to erode away. They were breaking these custom bearings within the forklift. They were something to the tune of $12,000 a piece. And they were breaking so quickly that they took a fleet of, I believe, 30 machines and had it down to 12 because they were cannibalizing all the parts. In reality, the floor repair only took maybe a week's worth of time to get these things fixed, and they wound up running through the better part of a global supply of these specialized glass bearings at $12,000 a pop. Oh. So it is often overlooked, and you're like, you kind of look at it and say, well, that was a solvable problem. And in that regard, we've had other experiences where, very, very large 800,000 or 900,000 square foot robotics machines have been put in only to have a utilization of around 30% because of the condition of the warehouse. We go in, we do some work, 30% becomes 99%, all floor related. So the success of their overall implementation does start with the floor. The hard part is getting that little bit of elbow room in the industry before the robots start to run and break.
Yeah. This is all good stuff, Derek. The one question I have for you on a new build, what is the ideal timing for you all to come in and do your work?
So I think for me, we try to say, when does the installer of the automation system come in? And then we try to back our schedule start date up from that, because I want to be able to say that we delivered exactly what they need the day that they put their boots on the ground. Because we are all dealing with so much in the chain of construction, right? Especially across the country, it's hard to say what each condition will be. Texas has expansive soils. We have curl up here in the Northeast. You guys have your trials and tribulations with cement. So we try to back up from when the boots will be on the ground from the automation provider and do our work then. That gives the concrete as much time as it can to do whatever it is it's going to do. Gives us some construction traffic, some ride traffic, some loading, things like that, so that we can better predict what we'll need to do to deliver the right floor.
Yeah. So is there a time when you're doing that, that back schedule, I guess, you're working yourself back and you're like, whoa, that's too close to the time we poured concrete?
All the time, because that's the way the world works, right? It's a minimum of 28 days really for us before we know that the concrete's cured out. I mean, that's just been an industry norm. It doesn't make a ton of sense, and quite frankly, it's more difficult to grind and be productive on those greener floors. So we do try to take the position that it's minimum of 28 days, but wait as long as you can. Let's see what this thing is going to do.
Yeah. Well, this was great, Derek. I appreciate you coming on the show today. I know we saved somebody oodles of money today if they listen to this episode.
I hope so.
Yeah. If folks want to reach out to you and, ask for some help, what's the best way to reach out to you?
Best way is you can check out our website. It's www.durablesurfaces.com, or you can reach me on my email. It's Derek, DEREK, @durablesurfaces.com.
A good deal. Thank you, Derek. Appreciate you coming on the show today. And folks, until next time, let's keep it concrete.